In this video, we're going to practice calculating probabilities using Venn diagram and tree diagram. In a class of 27 students, 13 students have brothers, 16 have sisters, and 5 have neither. Illustrate this information on a Venn diagram. If you notice, these numbers 13, 16, and 5 do not add up to 27, the total number of students. So 13, 16 is already 29, plus 5 is 34. So why? It's because some of those who have brothers and some of those who have brothers also have sisters, and some of those who have sisters also have brothers. So there's an intersection between these two information. Okay, that's why we have an intersection here. So let's draw the diagram. So the intersection, I need to draw like this one. Okay, so we don't know what that is, the intersection, meaning those with both brothers and sisters. Okay, but we can calculate that. On the left, we have those with brothers. On the right, we have those with sisters. In the middle, we have an intersection, meaning they have both brothers and sisters. And outside the circle, of course, those who have neither. So we have the number 5 here. Okay, so what's the number for those who only have brothers? So 13 students have brothers, so some of them have sisters too. So that means to say those with only brothers is 13 minus x. Okay, and because 13 minus x plus x is 13, 13 students are brothers, and those with only sisters, the number should be 16 minus x. Okay, now it makes sense. Now, how do we get x? Here's another clue. All of them add up to 27 students. So what we do is those with only brothers, 13 minus x, plus both with brothers and sisters is x, so plus x. With only sisters, we have 16 minus x, and those with neither, so let's call it neither, plus 5 must be equal to 27. Total of 27 students here. So this cancels out because minus x plus x is 0. So what we have left is 13 plus 16 minus x plus 5 equals 27. So this is 13 plus 16 is 29 plus 5 is 34 minus x equals 27. So bring this to the other side, we have negative x. 27 minus 34 is, or 34 minus 27 is 7. So that's negative 7. But we're not looking for negative x, right? So x must be 7. All right, so let's go back to our Venn diagram. I want to use black this time. So x is 7, and 13 minus 7 is 6, and 16 minus 7 is 9. Okay, 6 plus 7, those with brothers, makes sense, 13. 7 plus 9, 16 for those who have sisters. X, those with both brothers and sisters, 7 and 5. 6 plus 7, 13. 13 plus 9, 22, plus 5 is 27. Yes, makes sense. So we did this, letter A. Okay, now it says 2 students are selected at random from the class. Find a probability that both students have only sisters. Sisters and sisters. I want to use this time I want to use the tree diagram. On the first selection, two possible outcomes: boy, brothers, sisters. Okay, the probability of getting a student with brothers is 6 out of, okay, wait. Two students are selected at random from the class. Find the probability that both students have only sisters. Have only sisters. So this should be the branch we're dealing with, not this one. Have only sisters. The probability of getting a student a student who have student who has only sister is 9 over 27. Okay, and on the second selection, of course, what we have is brother, sister. So in this case, we only have 8 students left with sisters out of 26. So what we do is multiply those probabilities. So 9 over 27 times 8 over 26. When multiplying, make sure that they are in lowest term. I suggest you do that because if you multiply this 9 times 8, 72, 27 times 26, it's a big number, and then you have to reduce that to lowest term. Why don't we reduce them first to lowest term and then multiply? Okay, so 9 over 27 is actually equal to, well, 9 divided by 9 is 1, 27 divided by 9 is 3, times, we can divide this both by 2. 8 divided by 2 is 4, and 26 divided by 2 is 13. So that's simpler. So the probability of getting 2 or selecting 2 students with both with sisters, okay, is 4 over 39. So that's our answer.